Hi class, how are you? Hope you're doing well and getting ready for the last third of the class where we'll cover ANOVA, ANOVA, and ANOVA only. And so we're going to get started with the first and the simplest form of ANOVA we'll cover, which is the one-way ANOVA. And so let's get started. Hope you're doing well. So today we're going to cover the basic introduction to what ANOVA does, especially in its one-way form, and then we'll cover a demo together in our studio, and then it'll be your turn to get a practice at running this analysis. So let's talk about what ANOVA does. Now, ANOVA is an abbreviation for analysis of variance, and that makes it sound like we're testing hypotheses involving variances, but that's actually not the case, so don't be fooled. What it does is it tests for differences in mean scores among two or more groups, so it's comparing and testing for differences in means. The dependent variable for ANOVA is always continuous, and the independent variable for ANOVA is always categorical. And how many IVs or categorical variables you have and the type of variables you have determines which ANOVA you would use. And so in the lesson today, we're covering an instance where you have one categorical IV, and that's called one-way ANOVA. If you had two or more IVs, then you would have factorial ANOVA, and we'll cover that later in this course. We'll also cover repeated measures ANOVA, where you have a dependent variable that's measured multiple times, and so forth. But overall, if you have a continuous DV and categorical IV, then do consider using ANOVA. So I've mentioned that ANOVA tests for differences in means. And so the dependent variable, the continuous variable, provides the means that's being compared. And then the independent variable indicates which means are being compared. So for example, which groups are being compared or which measurement occasions are being compared. And so for example, let's say that you wanted to compare the height of athletes based on the sport. So maybe you're wondering whether baseball players are shorter or taller than basketball players and so on. Then the dependent variable would be the height, and then the independent variable would be the type of sport. Now let's talk about hypotheses. So null hypothesis, as you might have guessed, says there's no difference in means. The alternate hypothesis says there's at least one difference in means. Now notice that it doesn't tell you specifically which groups are going to be different. So you're saying that not all the means are equal. Written in population terms, it might look something like this. So population means don't differ, and that'll be the null hypothesis. And the alternate hypothesis says that there's some sort of difference somewhere in means. I think of ANOVA kind of like a t-test on steroids, because you can now compare more than two means at once. T-tests can only compare two means for you, but ANOVA can do more than that. So you might wonder, why not just run a bunch of t-tests then? Might be much simpler. Well, one reason not to do that is because running multiple analyses like that will inflate the risk of false positives. So you might remember the probability of alpha being that. And also ANOVA is one-stop shop, and so ANOVA can accommodate multiple groups, so why not just get everything done in that one stop? And so if you have more than two means to compare, I strongly recommend that you choose ANOVA. Now let's take a look at some of the key assumptions in ANOVA. First, you have independent and random sampling from the population. You also have normality, especially of your dependent variable, because that's the continuous variable. And then also homogeneity of variance in that DV. So homogeneity of variance, as you know, says groups have equal variance, and I've shown you this diagram before. And the null hypothesis for tests of homogeneity of variance says that the variances are equal across groups. And so you might remember that Levine's test does this. Now I'm going to walk you through a little bit of the under-the-hood information about ANOVA, and this is just meant to give you some exposure to the behind-the-scenes math that goes on in ANOVA. So you don't need to memorize any of this or derive any of this, but I just want you to get a feel for what ANOVA is doing. So to test for those differences in means, ANOVA uses variances, and that's the reason why it's called ANOVA, analysis of variance. And ANOVA uses the F statistic. Now, F statistic is calculated as the ratio between group variability, which is really the variance accounted for by systematic group differences, and within group variability in a denominator, which is often called error, but variance that was not accounted for by systematic group differences, so the rest of the information. An F statistic is calculated as mean square between divided by mean square within. And mean square is really average variance, and it's calculated as sum of squares divided by the degrees of freedom. And the formula for calculating those are like this, where x bar means mean for each group, so you're making these calculations and summing them across different groups, and k equals the number of groups. And ms between is calculated as kind of like average variance that's captured by differences across groups. And I've written down notation. Sum of squares is often abbreviated as SS, and then degrees of freedom, of course, is DF. And so this is SS between, and this is DF between. And then MS within is, as you might have guessed, the ratio between SS within and DF within. And it's essentially the average variability that was found when you look inside each of these groups. And so you essentially look at the variability inside each of those groups, tally it up, and then take the average. And so those are the mathematical calculations behind the F statistic. And then you get the F statistic, and all of that work was done for you by SPSS. And now you're ready to test your hypothesis against the F distribution, which looks something like this. And p-values are obtained from the F distribution based on the F value that you get and the degrees of freedom. So you need to know the degrees of freedom between and degrees of freedom within in order to figure out the probability. And of course, SPSS does that work for you too. So your job will be to take a look at the p-value and see whether to reject or retain the null hypothesis. So here's a quick summary of ANOVA. It tests for mean differences across groups, and so what it's doing is comparing mean scores and seeing if they're equal or not. And it uses the F statistics to test this. And what ANOVA tells you is whether or not there is any significant differences in mean scores. And so if you get a large p-value, so p-value greater than alpha, typically 0.05, then you can't reject the null hypothesis. And so the null hypothesis holds, which says that there are no mean differences, the means are equal. If you get a small p-value, less than alpha, or 0.05 typically, then that means that you reject the null, and you're able to say that there is some sort of a difference somewhere across the means that you have. Now the F statistic does not tell you which specific groups differ, and so if you get a significant result for ANOVA, which means that you get a small p-value less than alpha for the F statistic, then you need to figure out which specific groups differ using post hoc tests, and we'll cover that in the demo. And so do keep your eyes peeled for when I cover the post hoc tests. But in of themselves, the F statistic used in ANOVA doesn't tell you which groups differ, tells you whether or not there are any mean differences, that's all. And then you use the post hoc tests, which do typically pairwise comparisons. So they go and look at 2 pairs at a time across all the means that you are comparing and tells you which of those pairs differ. So we'll talk about post hoc tests during the demo section. And here are some terms to know that I believe you may already know. When you hear the word factor in ANOVA, they're talking about the IV, which is categorical. And then when you hear levels of a factor, that means categories within the IV. And so, for example, if you have 3 groups in your IV and I ask you how many levels are there, then the answer would be 3 levels. Okay, so now that you know the background information for one-way ANOVA, let's take a little break. Go ahead and review also, and then we'll come back and do a little demo with interpretation work. And so, see you shortly.